Okay, so we covered the in detail the different storage redundancies and talked about the scenarios where they are useful. So we move further. Next scenario in the storage world is if we want to have a queryable relational database in the cloud for transactional apps. Um, we have talked about the Amazon S3 bucket, right? The storage capability over there where each object has a unique URL, right? So if somebody asks you what is the unique feature or unique property of Amazon S3 or blob storage in Azure, so the answer would be unique URL for every object saved. Okay, that is the answer. And what are the handicaps or deficiencies of that system? That storage technology, it is not queryable. And if it is not queryable, it is also not searchable and stuff. Now, that was the first kind of services that were available in the cloud. But then afterwards, like the technology evolved, um, relational database services were also introduced, which is in the PaaS model, right? So till that PaaS model, how would you otherwise have a relational database solution in the cloud? Suppose this PaaS model where you deploy or use the Azure service, which directly is a database, and you can use the API to query and stuff, right? That suppose is not there, and you need to use cloud, but also must have a queryable database or queryable storage. So what will you do? Anyone? How would you enable a queryable database in cloud without this PaaS service or other if this was not available? Because you can imagine, right? Even if this PaaS service was not available, most likely than not, the any application that has a storage requirement with respect to or where it could be used the S3 bucket and stuff will also have a queryable storage requirement. For example, any application trying to upload some data like pictures or images or text or documents would not only upload them, right? They need to present it to the user in some form. And searching capability, naming the document, other properties of the document, when it got loaded, stuff like that, those could be associated or put it in a SQL database. So it's not only that applications will need to use the S3 bucket or blob storage, it is also that likely that it is in unison with the RDBMS that capability that the cloud application would need. So how would you enable this image and all this? We know we will be able to use the blob storage, right? But how will you enable the RDBMS on the cloud to make this happen, to deploy that application on the cloud? Any ideas? Did you understand my question? Did you guys understand my question? Any see, we have already discussed this, right? We have um, this answer to this question is from the discussions from the lectures that we have gone through already. So what is it? Anyone? How would you create an RDBMS database in the cloud? what with what you know already. Okay, try to find the answer and let me know if you have it. If you don't respond, I'll just continue to move in my slides. So, queryable relation database, what it does is basically, like we discussed in the scenario, is that we do need a relational database in the service, right? In the cloud apps. So, how do you provide that? So this RDBMS service as a PaaS service, platform as a service. You don't have to install the database, manage it. You just need to tell what kind of speed, throughput, IOPS you need, what kind of tier you need, and automatically that kind of capability will be configured for you in in these PaaS services for RDBMS. And obviously, it is at the back of this. Actually, actual RDBMS is there, and like SQL Server and things like that. And then obviously it can be queried as you want. So, but what it needs to do is dynamically scale, right? So we need to have RDBMS, or the cloud service provider will make sure that it is dynamically scalable. That is the scalability is the reason why we move to cloud first of all. So it got to be scalable. Then it should support the transactional processing. Anyone knows what is transactional process? What is a transaction in RDBMS? You would have studied RDBMS, right? So what is the transaction in when I say it should be a transactional? What does that mean?
When we run a query in RDBMS, that query should be atomic, so it should follow the ACID properties. So
Correct. So transaction means it's a unit of execution. So something is being updated, for example, and if that whole update has to happen, otherwise nothing happens. It's not partial update and then abort, right? So transaction has to be a meet the ACID properties, atomicity. So the PaaS service that these guys will introduce will need to be transactional, right? So that is the hallmark of RDBMS. It is transactional. So it has to be transactional. The service that uh, the cloud service providers will provide. So it is a PaaS service. So you don't have to do any infrastructure management, right? So this is the hint to my question earlier, that how will you create a RDBMS yourself? But this one is a PaaS service, so you don't have to worry about any infrastructure. And obviously, high availability has to be ensured, and also business continuity and disaster recovery in case of disruption, a large scale disruption that happens, like we have discussed quite a few examples, like what can happen and all. So in those that is called business continuity and disaster recovery, those capabilities. So what is the AWS solution for that? So AWS has this RDS service, okay, um, relational database service. So it basically okay. There is one more thing, right? So let's say Microsoft Azure wants to provide PaaS service for RDBMS. Now they have MS SQL Server, right? Their own RDBMS technology, but they won't ignore Oracle, right? They won't ignore um, MySQL or some PostgreSQL, these other SQL servers also, because they want clients to move to Azure and pay them, right? Similarly, AWS, Amazon, does not have any of their own RDBMS technology or databases, right? So they would want to design in such a way that they will have like an engine or something, which provides uniform capabilities to the instance that they create. And at the back end or the real database could be any of the technologies, could be any um, kind of RDBMS servers that are available. So obviously you will have for each server some connection or some tailoring, but this could be the architecture. And indeed it is that the RDBM, the RDS service of Amazon, it has a database engine, and then you can use MariaDB, MySQL, Oracle, PostgreSQL, MySQL, MS SQL Server, all these kind of databases you can pick, and the PaaS service that it will come out will have that kind of database at the back, right? So RDBMS of RDS of the Amazon is capable of providing a PaaS service on top of your pick. If you have a MS SQL Server license, for example, right, you can use that license to create that database in AWS RDS, and then um, that database engine of this RDS service will provide some API which your application deployed on AWS can use. Okay, and at the back, MS SQL there will be some kind of EC2 instance where your the DB engine or AWS, when it is getting set up, will install my MS SQL Server, will use your license that you have got, and then um, it will provide the service. Uh, License part, I am imagining it will happen like that, but we should check whether we can use our own license. It should be natural, because um, if I have a SQL Server license, I should be able to use it. I just bought it a couple of months back, and then I want to move to cloud. I should not be able need to wait for 10 more months before my license expires, and I don't want to pay double, right? I don't want to pay that license to RDS also. So RDS should provide a way to use your existing license, but that's not confirmed. Please check that out. Anyways, so the general architecture is this, that you have got a database class which you define what kind of setup you need, and then you create a database instance of that class. Okay. Now, DB instances could be magnetic, general purpose, provisioned. So these are like different tiers of or kinds of RDS that you can pick or create. And what is the basic purpose? In the sense that for starting or small development tasks, you can use magnetic. For any other general purpose thing, you can use any general database server, you can use general purpose instance. And if it is involving a lot of input outputs, then you can use this provisioned IOPS service, right? So the types differ in the performance characteristics and obviously the price. There are different tiers, and then you can deploy in multi-zone of the RDS, like we have discussed that they have different zones, right? So for higher availability. Then they have another uh, PaaS service that is called Aurora service. Okay, it is a MySQL service, MySQL and Postgres compatible relation database service. So it is not the it is not capable of having Oracle and MS SQL Server at the back. So they have created a separate Aurora service which at the back will use only MySQL. So MySQL and PostgreSQL compatible, meaning MySQL, any MySQL type of database or PostgreSQL type of database can be used. So, for example, this MariaDB is a MySQL kind of database. It is built. It's like Android, and then some uh, company using Android OS and tweaking it to its changes, right, to its different looking UI or some other capabilities. But underlying, it is Android. Similarly, MariaDB, underlying SQL database is MySQL, but it has got its own brand. So so therefore Aurora service can be used with MariaDB or MySQL or PostgreSQL, and it is a obviously relational database service. So there we define a DB cluster which could be spread in different availability zones, right? And you define one as your prime replica, primary instance, right? And the other zones will have the replicas. Okay. So what it means to have what is the difference then? What is about primary which is not there in the secondary or replicas? The write capability. So the write will happen from prime to the primary instance, right? And then it will automatically write, or the write will spread to the other availability zones, right? So the write is happening to a database disk, or what you say is a volume in the volume, and that volume is like connected together through VPN or through fiber optics cable, because these are in the same database cluster. So they have high fast write capabilities to the zones, and then you can use this replicas for reading purpose. Okay. From primary instance, both read and write. From replicas, only read operations, as you can see. And the primary instance writes to the volume, which is shared or cluster volume between different replicas. So, so the endpoints, the cluster, the reader, and the instance. So it will the user will get to connect to the cluster, and then the reader, meaning for the read only operations, and instance, which is the primary instance for write and read operations. So there are two kinds of PaaS based database services, which are RDBMS services in AWS. If you want to use Oracle MySQL Server or MS SQL Server, then you switch to AWS RDS or use AWS RDS instance. If you are on MySQL and PostgreSQL, there is a dedicated service which takes care of more things for you, right? Automatic scaling and things like that. Uh, if you are on MySQL or PostgreSQL, want to work with the Oracle or MS SQL Server instances. So that is the main difference between those two things. So what is the Azure's solution? What does Azure provide for PaaS-based RDBMS? So it has a SQL database service. It is um, based on the MS SQL Server based, okay, and it you can create three kind of instances: managed instance for migration scenarios, where you need to, let's say, have you already have my MS SQL Server on your on-premises servers, right? You have a database, now you need to migrate to the SQL database on Azure. So you can create the schema as it is, or migrate the schema as it is, and migrate the data if you create a managed instance. So basically it is still an instance, but Azure is managing it for you. So you can easily migrate your data from your on-premises SQL Server to a managed instance, and nothing will change basically other than the connection string. All your queries, everything will just look like the same. So it is a quick way to move to cloud if you are using a MS SQL Server by using managed instance type. Then you have single instance, so single isolated databases for dynamic scaling. That is the dedicated, I would say, a service which offers dynamic scaling. And then you have elastic pool, which is where you define some resources and then they are pooled together to be consumed by the databases. For this is for unpredictable loads. So if you are not able to anticipate what kind of load will come based on different situations, different time, day, weekend versus not weekend, and things like that, holiday versus not holiday, unpredictable loads, or it is something related to market and other kind of volume data that is more transactional, things like that. If the load is unpredictable, then you could use elastic pool, which will deploy more resources from the pool if um, the requirement requires so. Okay, so three different kind of instances: managed instance, single like the regular instance, and then the elastic pool instance. Um, Important to know about the cost model also. DTU based. Um, let's see what it says if I have any notes. Okay, so let us go through the notes so that we don't miss anything. Um, Single database. It has its own set of resources managed by a logical server. So logical server is what PaaS is all about, right? So it has its own database resources, but in the Elastic pool, a pooled database with a shared set of resources managed by a logical server. And managed instance is a collection of database that contains system and user databases sharing the set of resources. So, like we discussed, right? Now, DTU is the unit for costing, how much it will cost you. So database throughput unit. So it is defined in terms of how much capability you want from your database, and DTU is a unit. So it will depend the DTUs, how many DTUs gets consumed by your service is how the billing will happen. So it is based on the database throughput units, or you can have the earlier version which was the V core based, the core or the CPU um, unit, how many cores you are deploying in your database, and there they will be based on that, meaning um, if you deploy a larger core or more number of cores, it will cost you more, right? Apparently database throughput unit is looks like to be more um, fine tuned to kind of pay as you go kind of service, like how much ever do you use, that much you will get, right? Vcore is more like a VM. You create the VM and it is charged by that, whether you use it or not, it will be charged that way. So database throughput unit, you should study about more about this, what are the details of how the costing is calculated through database, through throughput unit and vcore based instances, and how they are different and which one should be used when. Like I said, in cloud, one of the primary things to keep in mind even for us developers is cost, right? So you should know which one of the two you should pick and how the cost is determined. Okay, so that you can take up as a exercise or homework. So like this SQL database service, Azure also provides services for MySQL and PostgreSQL, and you should also check if Azure has now also a PaaS service for that supports Oracle. So check that out, because these nodes could be little older than, and new developments and keep coming. So let me know so that I can update my notes also. So two things for your homework. One is What are the details on DTU and vCore based costing in Azure? Um, with some examples like how the costing will happen, right? Which one should be used when? Okay, what is the recommendation by Azure? And then um, what are the Azure solution for if they are there for Oracle databases? Okay, so those three things you should find out. Okay, so now we come to the most important technology disruption, I would say, that the cloud has made in at least in terms of database technology. Okay, and that is NoSQL databases. Okay, um, NoSQL databases. I'll talk in general first, and then we will come to the things that this guy is discussing. But I want to start with a caution, okay, because I have seen this multiple times and I want to caution you on that, given that, and you can take it as authentic because I deal with these kind of situations in real world scenarios also. Okay, I take up the projects and we face this issue. The because NoSQL database are easy to set up and like for example Firebase and stuff like that are available by default. It is a tendency of students to pick by default the NoSQL database and be happy with it. They pick because it is easy to use. They pick because the service is available, right? No, nothing wrong in that. But slowly that gets translated to an understanding that NoSQL database is suitable for every scenario. Apparently, that is not true. Like I said, I have worked on a project where we migrated whole database from NoSQL, what is that? MongoDB server to MS SQL server. From NoSQL database to MS SQL database, a relational database, because nobody thought about the scenarios and just used my MongoDB, and it became difficult for them to work with that instance. Okay, so don't assume NoSQL database is the right choice for a particular situation that you're trying to find solution of. It might seem it will work, but you need to dig deeper. And obviously, like I said many times, if you want to dig deeper, you need to know the technology deeper. So I am assuming you know RDBMS quite well because it is taught in as a core course and almost everywhere it is required. So you already know about RDBMS, and in the next few lectures we will talk about NoSQL databases and what, to my best understanding, I have come to understand about them, and then we will try to come up with few exercises or examples where we together will discuss and see how NoSQL database could be used or whether it should be used. And so that is one part of the scenario. The second part is, I just said that you guys already are very, very familiar with RDBMS, right? Relational Database Management, which is transactional. Now, it is a tendency of students to apply that knowledge on NoSQL database as it is. That is also not correct, as we will see in some of the discussions we'll have. So both ways, you need to be cautious about what you're doing. Using NoSQL blindly is also wrong, and applying the concepts of SQL database on NoSQL is also wrong blindly, right? You need to understand or you need to know what you are doing. Don't assume things in technology. There is no assumption in technology. It is all logical. It's all understanding based, right? So, and NoSQL database apparently is a very, very popular, very important disruption that was made, and is a very useful way to store data in the cloud. But it has got its limitation, it has got its advantages. You need to be aware of it and how we need to use them. Okay. So what was the motivation to for NoSQL databases? Bigness. Okay. So um, the advent of cloud led to availability of applications throughout the world, right? And like Amazon and all the applications are basically gathering data from different sources, different people, different phones, different devices, right? So the large amount of data um, makes no SQL servers or SQL databases, RDBMS databases, not so suitable. Okay, so NoSQL is the key part of new data stack supporting big data, big number of users, big number of computers, supply chain, science, stuff like that. So when you have large, very big amount of data, which doesn't need transactional processing all the time, or it is only partially needs transactional processing, then you don't need to use RDBMS. Of course, RDBMS can be used, but it could be an overkill. Okay, so for example, you want to query only some portion of data. You don't have to query everything else. So why put everything else also in columns? Right? Because columns basically give you searchable data, right? So why do you want to do that if it is not required? So therefore, the big data could be is a bag. The NoSQL databases are fit case for storing big data, whether it's a big number of users or big number of computers or big supply chain data, big science, right? Genome sequencing, DNA sequencing, and stuff. So that is the large volumes of data where NoSQL is likely a better fit than RDBMS. Then second, data is stored all around in a distributed manner. It does not fit well with RDBMS. This is, I think, the core part, the real um, value that NoSQL brings. So what happens is the data, because of the globalization of applications, and we want to store the data in different locations, either for high availability or for disaster recovery or for a better user experience. The basic what we end up doing basically is to spread the data across different regions in the world, right? Now basically we are storing the data all around in a distributed manner. But so imagine if we have these um, nodes in our RDBMS. So like the database node. So this is DB, same database. Let me draw like this. So database is here, but it is spread in different parts of the world in terms of nodes, right? Node in some region one, region two nodes, and so on, right? Region N. So when the and suppose this is our DBMS database. So when data comes, a command or what you say write operation comes. So the write operation is happening, and let's say this it is written over here. Okay, in this region it is written. Then the query node comes, or the query is. Can you go on mute, please? Somebody is. I am listening to my voice. Yeah. So if the query comes and let's say the query goes to our N database node, So the result should be the state that is here, right? That is the property of RDBMS, that once the data is committed, if you query it back, you will get the latest state. That is the transactional thing, right? So no matter what internally this DB is doing, how it is deploying the data and all, it has to meet the RDBMS characteristics, right? So the result, no matter from which node it is read from, it must be equivalent to as if it was read from R1. That is the guarantee that RDBMS provides. So that means we cannot say, or that means this write operation cannot return back as success, return meaning or finish, until data is returned to all the nodes, right? Because that is the only way, after this finishes and immediately a query happens, I can return the data which was just written, right? Now you can imagine if these nodes are located at different places across the globe, it will take a lot of time for the write operation to finish, because it has to be replicated first to all the nodes, then only it is committed, and then only the query or the SQL command can return back saying the command is successful, right? Because we never know immediately when, from which part of the world that query will happen for the data. So, and it has to be returned properly, right? So that is why the RDBMS is not a right choice for data that is distributed across the world because of this node. So now you keep that in mind. RDBMS has to be RDBMS, right? It has to be a transactional ACID property holder. It has to meet that. So it cannot say I will write to this node first and then asynchronously replicate to other nodes. That is not the right solution. Why? Because if the read happens from this location, then it will return different data, because the same table got updated in the previous node and it hasn't synchronized here till still. So that is the break of this ACID property, right? You are saying from this node there is one state of the data, and from this node there is another state of data. That is not RDBMS then, right? So if it is RDBMS, it has to return the same state of the data. So apparently you can imagine, like we discussed also, that updating the what do you say? Updating the data in different nodes in a distributed manner is not a fit for RDBMS. So that is why NoSQL database come. Now you might get questions that might be thinking that how then NoSQL manages it. We'll see. It does not manage it actually, because if you want to ensure transactional thing, then you better use RDBMS, right? So um, then second motivation to use NoSQL, high volume. So high volume database, volume data, like we talked in bigness also. Um, for that kind of data, NoSQL databases are more useful than RDBMS. Like Facebook needs to store 135 billion messages a month. Twitter has problem of storing 7 terabytes of data per day. So all these things needs to be distributed properly, right? It cannot be one data center, it cannot be one database. So how do you manage all that? Such a high volume of data. Then um, fast key value access. So most NoSQL solutions provide a hashing on the key and then reading its value directly from the memory. Right? In NoSQL databases, this is the key technology, key value pairs. Okay, The key is a hash value, hash of some property that you want to store. And if you make that value, meaning that property as a keyed value, you can directly read it from the memory because hashing is very fast, right? So almost it's a constant time. In ideal case, hash function will take a constant time. So if you want some fast access, you can put that fast access to a property or data. You can put them as a uh, key value pair, right? And then that fast access will be available. That value will be available very quickly using hashing technology. So that NoSQL solution provides. Okay. Flexible schema and flexible data types. So this is also an important thing. Um, Once the column or schema of a RDBMS is defined, it is very difficult to, I mean, alter it, or you say the data that is incoming has to meet the schema of a table for it to be possible to get into it, right? So now there are solutions to that, for example, nullable fields and stuff like that. So if object is coming from outside to be written to an RDBMS table, object's properties have to match to the um, columns, right? Because you need to know for which property has to go in which column. And if some of the columns are not defined, you can opt, some of the columns are not available. The properties of the object does not have all those columns defined, then you can opt to set null. Okay? But technically, what you are doing, or conceptually, what you are doing, you are updating the or you are changing the schema of the object so that it can fit to the schema of the table, right? Now, that is a thing that you need to do on the object. So it means if there is a flexibility in the schema and flexibility in the data types, that will be more useful in this scenario where one object is having some data, one object is having other data. Okay. So flexible schema and flexible data types can, if they are there, then NoSQL could be more or a better solution than RDBMS. So NoSQL products support a whole range of new data types. Complex objects can be easily stored without a lot of mapping. Like I was talking about mapping between properties of the object to the columns of the RDBMS table, that has to be one-to-one direct mapping. And so much so that there are frameworks for you to do that, like Object Mapper or Entity Framework. They do this translation or mapping from an object to uh, table and vice versa. So lack of structure allows more flexibility. The lack of structure, uh, which we are saying about the flexible schema, right? So structure in the sense that this mapping between object properties and the columns uh, need not to be perfect match. So if there is a structure defined, if on the right side RDBMS I have defined a structure, then there is no way out, right? Then you have to put in that structure any object that comes by retrofitting it. But if on the right side you are the RDBMS or the database technology that you are using is allowing flexible data, meaning, for example, it says you have only two things essential and rest is flexible, meaning having it or not having it doesn't matter. Then it is good. Your essentiality becomes only two properties. Rest of the object can have anything. So that is a flexibility, right? So these scenarios, bigness, high volume of data, fast key value access, and flexible schema or data types. If your database requirements are like that, then you can use NoSQL database in a it is more appropriate. It will be more useful to use NoSQL database. It is a better fit to these scenarios than a typical uh, RDBMS. Meaning now bigness, high volume, these two things um, are there definitely, but more likely than not, you are going to not hit them because not many companies have this kind of data that is coming in. Still, RDBMS is used like anything. Okay, so it is likely that in many scenarios that you are going to hit in your careers, RDBMS indeed actually be a better fit than a NoSQL database. So you need to be careful about it. Okay, just because NoSQL database is cool thing to do, shouldn't use NoSQL. Like I said, we had to company had to spend time, effort, and money to move from NoSQL solution to a SQL solution. So there are scenarios like that. So be careful. Okay. So a lot of positive about NoSQL, but what is the cost? What those things that are there, which NoSQL cannot provide, which RDBMS can provide. So we need to be careful about that, right? That we things that we take for granted in RDBMS may not happen in NoSQL. Okay. So therefore, you can see transactional atomic writes. It cannot hold transactional process. Indexing of non-key columns. If you this is was key value pair, right? Key value pair. So this is value, you can think of it as a column, and key is the index of that column. So then it can quickly find the values in that column. Any row it can find. But what about the other columns, right? You cannot define everything as a value and key. Okay. So if you have non-key columns, you can index them in RDBMS for faster query. Not possible in NoSQL. Okay. Query optimization, not possible in NoSQL. Declarative set oriented queries are sacrificed. All these things are sacrificed in NoSQL. So these things are not available uh, in NoSQL, which are granted or are considered to be first class citizens in RDBMS. So that is the reason. Now, transactional atomic writes, right? This is the fundamental concept in RDBMS, and it is not applicable in NoSQL. That is why I was saying, not, I mean, RDBMS concepts cannot apply as it is to NoSQL because there are fundamental differences between them. That is why I was cautioning you not to think in terms of RDBMS when you are designing a NoSQL database and vice versa. Okay, because of these fundamental things that are taken for granted in RDBMS not being available in NoSQL. Okay, so um, NoSQL provides AP of the cap theorem. So anyone knows about cap theorem? Have you? I think in the database world, you would have studied it. Have you studied cap theorem? Studied or at least know about it? Anyone in your RDBMS or database related courses? So cap theorem is basically what it says is that no database can provide all the three at the same time. Consistency, uh, what was A? Availability or atomicity? Let me check because recording. Not in my
Sir, it's availability.
availability. Okay. So CAP theorem says consistency, the data is about data only, right? Consistency, availability, and partition tolerance. There are three of these properties. Any database cannot provide all three at the same time. You have to sacrifice one to get the other two. So the SQL databases, they sacrifice partition tolerance. Partition tolerance means the data cannot be split between nodes easily, right? The scenario we discussed where the database was writing to different nodes, it was doing it for management purpose, management of the data. But for the user, it was same data, right? It doesn't matter whether there are 10 nodes used or 20 nodes used. It has to be transactional, right? So it has to be consistency, and the data has to be available once the write is completed, right? So it has to wait. So it cannot manage the partitions. It has to wait when every partition is written to. Basically, it means that all the partitions are considered like a one unit, right? Because you are writing to a partition. Now that partition is consisting of 10 nodes or 5 nodes or one node, doesn't matter, because all the nodes has to be written. So there will be only one logical partition in the SQL database. So there is no tolerance on partition. You cannot partition the data. If you do so, you sacrifice that and you get what? The beautiful consistency and availability. Once the data is written, it is written and it is available to for the querying part. Now, NoSQL, what does it provide is it provides availability and partition tolerance. You can write the data in a distributed way quickly, but consistency is sacrificed. What does it is a big statement actually. Consistency in sacrifice, and it is a new thing for us because consistency is always granted so far in everything that we have studied. Right? Once written, it is available everywhere, even in the storage technology of S3 or blob storage. Once the object is written, you have the URL, you read it from everywhere, the same object will be returned. Right? But coming back to the SQL part, we have always assumed in RDBMS, once the commit is done, the query returns or the command returns to write to the database. No matter when and where you query it again, you will get the updated data. So it is consistent. But that key thing is sacrificed in NoSQL database. So that is the most important thing to understand. Consistency that we assume will be there in RDBMS system is sacrificed in NoSQL. So keep that in mind because this leads to a lot of different concepts that are applicable in NoSQL, and this should disrupt your thinking of or applying your knowledge from RDBMS to NoSQL directly. Consistency is sacrifice. Keep that in mind, and then when you apply, think about that. That is this good way to do it or not? Because consistency is sacrifice. Now, um, another important thing which I will talk about now is based on this consistency. Right? If somebody can ask this, right? If consistency is sacrificed, then what is the use of NoSQL? Right? So it is important to understand this. We discussed that, right? We had this DB that we said this is our RDBMS instance, and it is writing to different nodes, region 1, region 2, region 3, and so on, and region N, right? Write happens to all nodes, and then you read is matching the write. Whatever you written, um, it is getting read back, right? This is the this is consistency, right? But when I am saying it is a NoSQL database, write happens to, let's say, R1 and R3. This when the read happens, this may not be true. That is, if an object is O dash state after the update, and here the same object, because it is copied, right, is in O state, when the read happens, it could return O state instead of O dash, right? So that means if this write is, let's say, um, updating the price to an of an object to 100 from 80, this becomes 100, this is 80, this is 100, this is 80, right? So when I read it, it might still return 80. So the user who updated it to 100 might see 80 and think that this is not working properly. I am still seeing 80 even after the database saying I am done writing, right? So this is not consistent. There is some problem with the database, right? Obviously there is a problem, and the data that is returned should return 100 for this user, right? But if that is the problem, then why NoSQL database is useful? The answer is, not all scenarios need consistency. That is the answer. Need, I would say, okay, let me keep it simple. Consistency or immediate consistency, like we discussed. So this is the answer to that question, that why use NoSQL database? The answer is, not all scenarios need consistency. Okay, I think we talked about this earlier also. If I am giving you, I am giving a catalog of items to view to the user, and then some update has happened to an item. So the user or the buyer on, let's say, Flipkart is viewing an item, right? Some item is getting viewed, right? And then therefore it could be happen that many buyers are viewing that item, right? So this is your inventory of the same item. Inventory. Currently there are 2 items available, right? And then here it is saying available. Its state is available, though it says only 2 left or 2 hurry or something, right? 2 left, something like that happens, right? Now somebody else buys it and these 2 items get booked. So 0 items available. So in the inventory database, now the data has updated from 2 to 0, but here it is still showing 2. Okay. Now the question is this tolerable? Yes, because ultimately when the user is going to buy it, which is only, let's say, 2% of the time, or 5% of the time out of 100 times I am viewing just the items, then the item will say that it is just has become not available, right? So it might um, prevent the user from buying, but it has not prevented the item from getting viewed and stuff by the 98% of other users who are only going to view it. It is still the older version, but they can still see the data, right? So I'm okay if you ask me from a Flipkart business point of view, which one you choose. The buyer will not be able to see an item. Buyer not seeing an item until inventory updates, until inventory, sorry, the writing is on this thing is bad. Inventory updates. Okay, that means for few seconds, 10 seconds, 15 seconds, buyer will not see this item. It will wait, because the consistency is happening. 2 to 0 is getting returned to all the nodes here, and then only it will return success, right? At that time, nobody will be able to update or read the data, right? So buyer is not able to see it for some time. The second scenario is buyer is able to see it, but with the old inventory, and I can guarantee you that it will be zero if buyer goes to actually buy or order the item. Then it will come. So obviously, the Flipkart business will pick the second choice, that I want to show my item to the user. Right? In the meanwhile, it zero item may become 10 again while the user is viewing it. So the user may not even see that there was a zero item left in during while the user was looking at the item. Right? So obviously, this is not a consistency scenario, right? It is a AP scenario. Availability, item is available, meaning you can see the item, and it is not consistent, but it is available. That works, right? So consistency is not always required. So that is why NoSQL database is suitable in places where consistency is not required, and that is the key thing. And we will spend a lot of time in discussing, understanding that part, because that changes many things. Okay, but theoretically, in general, in NoSQL databases, A and P of the cap theorem is provided, consistency is sacrificed. In RDBMS or SQL databases, P is sacrificed and C and A is provided. Consistency is provided. Partition tolerance is not. Partition tolerance, what is that? Partition, the data cannot be partitioned. It is always the volume to which the data is written is always logically a single volume, meaning even if it is split into different volumes, everything has to be written to the all the volumes, and then only the data has to, or the commit is successful. So logically, if you think, all these 10 volumes are basically one volume only, right? So partition tolerance is sacrificed. You cannot partition the data. The database cannot tolerate partitions in the SQL database. So that is the key difference between NoSQL databases and SQL databases. Consistency is sacrificed in NoSQL. Consistency is not sacrificed in SQL. Partition tolerance is. That results into all these um, deficiencies of NoSQL. But despite all these deficiencies of NoSQL, many scenarios are falling in this category where I do want to let the data flow to the users, even though it may not be consistent, right? So, um, very important thing. Okay, so categories of NoSQL databases. There are different levels of sophistication in the NoSQL databases. So, what are those, right? Key value stores. Some databases are simple hash tables, key and the value stores. So the data is stored in a key value pairs. Okay, and um, so this value could be a large object also, right? It could be in multiple, what do you say, megabytes at least. The key is basically an indexed value of that object, or you can define it in a way depending on the technology of the NoSQL that you are using. And you define a key, and then it will map to the value. Obviously, then you can query on the key, or you can search for the key, or you can ask that what is the value of this key, and quickly the answer will come back, right? So, in many scenarios, these key value pairs are basically a good fit. So, directly key value stores are there. Document stores. uh, the object, this value is considered as actually as a document. So it is stored as a document against a particular key. So basically, value is thought of or designed or talked about as a document. Document you can think of as an object, or it is a blob. It is something which need not to be looked into because you have got a key to that document. Okay. Wide column stores. Um, it is a semi-schematized and semi-hierarchical thing. So NoSQL tables have a definite schema. They define the columns properly. Every column has got a name, has got a type, right? And the limit and stuff, right? But wide column stores, you can define some of the columns, and then some of the columns are not required to be there in the object. Let's say flexible or semi-schematized or semi-hierarchical thing. Okay. And then we have got the graph databases, which explicitly track the relationship between entities. Meaning the graph database track the relationship between entities, how two entities are related, what is the relation type. So it's like a database, the graph data structure. One um, vertex linked to the other vertex through the edge, and that edge is the relation's name, right? Um, Lavneet Singh, DICT, relation name faculty. DICT is a node or vertex. Lavneet is a node or vertex, and edge defines the relationship. Okay, so those kind of databases that explicitly track the relationship between entities are also NoSQL databases. So these are all NoSQL databases. None of them guarantees consistency, okay, but they offer a lot of flexibility in terms of partition tolerance, the high volume of data that can go into these, right? So we will study these databases in detail in the next lecture. Any questions so far? All right, then if you don't have any question, we can stop the lecture.